Hey, what's up guys? Welcome to Developer. In the last video, we discussed about what function pointers are. We started with an example of where the function pointers could be useful. Then we went on to see how function pointers are implemented in C and C++. Well, this video is going to be an extension of the last video. If you haven't watched the last video, I'll put the link in a card up top and also in the description, so make sure that you watch that video to get an idea of what function pointers actually are. This video will make a huge lot more sense to you in that way. Let's start this video and let's go over some other popular programming languages. Before I get started, let me organize my directory structure real quick. Public class app. Okay, let's have our main. The way function pointers are handled in Java is, since Java has no concept of pointers, it has only references. It's the closest thing we have to pointers in Java. Java developers, what they did, okay, so I need to declare package declaration. The package name is Java. So the way the Java developers implemented this was something known as functional interfaces. Functional interfaces are an interface which has just one method in it. This method is exactly the one which is your function pointer. So let me just show this because it's best explained with an example. I'll just create a interface default with default access modifier because I don't want to be creating it in another file of its own. Interface fi, just naming it for the sake of it. We'll have a very simple void print which takes in nothing. This is a very simple function, takes in nothing, gives out nothing. This is your print function. This here is a functional interface. If you even do not annotate it with functional interface, it will still work the same. The way we can use it is we can have a private static function f which takes in fi. Now fi becomes the type of the function pointer, and what gets assigned to it is could be a lambda or another interface implementation actually. So what we can do over here is have an fi and we can call print on it. Okay, I'll need to specify the return type. You will have to explicitly call that particular function like this. You can't just do this method, which is basically the only one which is declared in that functional interface. Now you can assign values to it in such a manner. So you can use lambda expressions which were introduced in, I think as far as my memory goes, Java 8. This is a lambda which takes in nothing, and if you return nothing inside of it, then it returns nothing. We'll just print hello world. That is it. Now we can call func with our fi. Let's compile this. Let's change to the directory java app.java. Okay, we can't have package name as Java. Let's name it Java fptr. Okay, so this is we need to update the package declaration too. Once that is done, we can, as you can see, we get hello world. Now we could have, if we wanted to, assign this thing directly over here, get rid of it. It would still return hello world. So what we are doing is, so we are not explicitly declaring the definition or the implementation of this print function. We are using a lambda function, and when the lambda function is going to be assigned to a functional interface, the Java compiler already knows which method to bind to the implementation, and it does that. But when you try to call it, you will have to explicitly invoke that particular method which is declared in that functional interface, the one method which is declared in that functional interface. That is how Java does this. Let's move on to another programming language, C sharp. C sharp. Now what we will do is we will change directories. We'll create a new .NET console application, name it fptrs. Let's wait for it to create the application. Okay, now it is done creating the application. I can open the program.cs file. So Java, well, C sharp for the most part has been actually Java++, but C sharp recognized this as not a very nice syntax. What Java implements for function pointers, C sharp saw this as an opportunity and created something new completely. C sharp created delegates. So to use delegates, we'll first have to create a class. Nice. We can svm, yeah. There's our main. Let's create a print function. We also need to provide the definition console.writeLine. That's a very simple print function. Let's now create a function pointer. Well, the function pointer needs to be created as a member of the program. Unfortunately, you can't be doing it in the main method itself, because it's actually first you need to declare the type. That happens by writing the delegate keyword. Well, there is the whole world of unsafe and safe context of C sharp, where unsafe you can use pointers, and in the safe world you are not allowed to use pointers, you are only limited to references. Also, when you are in the unsafe world, you would be writing delegate pointer as such, and the whole another ball game of declaring the calling convention and whatnot. Well, let's, for purposes of this video, limit ourselves to the quote-unquote safe side of C sharp, and let's stick to the plan, not diverge ourselves. So we'll declare a delegate, this particular syntax, delegate, then the return type of our function, then the name of our function pointer, where we'll be declaring the type. So it will be function pointer type, and then the signature list, or the parameter list rather, of our function. Since print takes no argument, it is going to be empty. Over here you can create a private static void func which can take an fptr type fp. Okay, now we can call fp like this. Well, that's pretty much to it. All that remains is to call func with the function pointer. So you can do it, and it looks really very similar to JavaScript, and you don't write anything. Well, for this example we can choose to not write anything, um, or we can pass in the print function directly. Since it's non-static, we can make it static. Now it works. What we expect here is for us to see hello world, and well, let me add something over here, console.writeLine testing lambdas. These are C sharp lambdas. Now we can run it. That's your output, hello world and testing lambdas. So you can directly provide the print function like this. So this looks very similar to C++ kind of syntax, and this looks very similar again to C++ syntax, where additionally you had this captures thing and you didn't use any kind of arrow keys, well, arrow symbols like these or this. You just straight away started writing your lambda function. Here you need to specify it with this arrow. Yeah, that is it. That's about C sharp. Better than Java, but still you need to mess with all these type informations. So, well, what if I say you there are programming languages where you can get away with defining any kind of types? Uh, those are dynamic programming languages. You might already know Java, Python. We can just look at Java and Python in this video. So, well, not Java, JavaScript or JS. Let's create a new JS project. Let's switch over to JS. Let's create a new project. cdjs npm create. We'll leave everything at default. We will create an index.js file. It's really very simple in JavaScript. All you need to do is create your function like this function, um, which might take in, let's not take any arguments for now. Print, and it will print hello world. Seems to be our favorite string to print in this video. We can have our main function. Well, let's not bother writing it. We can just call, we can store the reference to print in some other variable like this variable, or rather function pointer. We can just do it like this, and then we can call print in this way or in this way. No type information needs to be associated at all. And if you call print in fptr, what you expect is seeing two hello worlds on the screen, and that's what we get. Let's clear the console. Okay, so that is very much it about JavaScript. Let's quickly move on to Python. So we'll create Python directory, and herein we'll be creating an app.py. Okay, so here we are in app.py. Let's quickly write the basic boilerplate. If name equals main, calling main, we'll define main as an empty function for now. Let's have a function called f. We'll print f in it. Well, I'm getting bored of calling hello world, hello to the world, with no one calling me back again and again. So I'll call f. Now let's call f. The way we store a function pointer is just by creating another variable and assigning it to that function without the parentheses. If you provide the parentheses, then it will assign it to the return value of that function. Now g becomes a callable. G is a function pointer to f. You can call f in this way as well. So what we expect is to see two f's on the screen and a new line character. Let's add this for that. We see two f's getting printed on the console. Well, that is pretty much it about function pointers in Python. It's very similar to JavaScript. Here you see we assign fptr equals print. Here we assign g equals f. Quite the same thing actually. Semicolon at the end is optional in JavaScript, so it is roughly the same thing, if not the exactly same thing. Well, another use case for function pointers, if we are talking about in Python, are decorators. Well, decorators are special functions which take in functions and might take some arguments. Well, in its most basic form, decorators are functions which take in another function. Well, what is it taking? It's not taking another function, it's taking a function pointer. Well, let's create a decorator, or let's make f a decorator. It will take in a function pointer, and we declare another function body inside of f, and yeah, this will be accessible outside of f as well. This is Python, this works. If it would have been C, C++, you wouldn't even probably be able to declare another function inside of a function. Well, by the way, this also works in JavaScript, so yeah, this kind of syntax is valid over there too. Yeah, so def g, what we do over here is, well, we can first print g, and then we call fp, and yeah, that's pretty much it. What we do over here is, well, let's get rid of this. We return g, the one which we declared inside of f. Let's have a decorated func. This decorator, let's print f inside of it. And yeah, decorated func, well, f is our decorator, and we decorate this decorated func with the decorator f. Now what happens is, let's get rid of all these. So now this decorated func, what ends up happening is decorated with f. So the value fp which gets in passed to f is actually this decorated func which we have annotated with f. Decorated func gets passed into f, and then we define another function g which first prints g and then calls the function which gets passed to it, in this case decorated func. In decorated func we print f and we end with nothing. Let's add a new line character to it. Okay, what happens now when we call decorated func is what ends up getting called is this modified function g, which will print g and then call the decorated func which will print f. So what we end up seeing on the screen will be gf, as we expected. Now let's take a minute and let's actually see what ends up happening when we called decorated func. So what happens is that we are essentially passing decorated func to f like this. So the function pointer reference whatever gets of decorated func gets passed into f, and then inside of f we define g and we return g. G is a callable. So what ends up happening is that we call f which returns a callable and then we call it basically. So calling a decorated function is equivalent to calling it like this. So this ugly syntax gets replaced by just simply decorating the decorated func with f. Let me comment this out and comment this out as well to show you what is that this is what is actually indeed happening. So we see GF getting printed onto the console. Okay, so that was all our function pointers in Python, and we briefly touched upon the concept of decorators. Well, there are more to decorators, much more to it indeed. I briefly touched upon this as I said, but yeah, this was again not a video on decorators, it was indeed a video on function pointers, how different popular programming languages implement the concept of function pointers. Well, that was it for this video. Let me know if you have any suggestions for this video, something you wanted more out of this video, any feedback in the comment section down below. If you like this video, make sure to like this and subscribe to the channel if you haven't yet already. I'll see you in the next video. Till then, keep on learning, keep on growing, and bye bye.